Forces and elasticity. In physics, force and elasticity are important concepts that explain how objects can change shape when forces are applied to them. You can deform objects by applying force to them, causing them to change shape. There are two main types of deformation. 1. Stretching, when forces pull on an object, making it longer. 2. Squashing, when forces push on an object, making it shorter. Springs are special because they usually spring back into their original shape after the force has been removed. They are elastic. Work is done when a force causes an object to deform. This means energy is transferred to the object, causing it to change shape. You may remember energy transfer in our last sections. Work done is the same thing. Energy is transferred, and work is done when an object is deformed. For example, when you stretch or compress a spring, you're doing work. This transfers energy to the elastic energy store of the spring. When the spring springs back into its original shape, the energy in the elastic energy store is transferred to its kinetic energy store. Hooke's law describes the relationship between the force applied to a spring and the extension, stretching, or compression, squashing of the spring. If an ordinary metal spring is supported at the top and then a weight is attached to the bottom, it stretches. Hooke's law says the amount that a spring stretches is directly proportional to the force applied. This is F. This means that the relationship between force and extension is linear. K is the spring constant. Its value depends on the material that you are stretching, and it is measured in newtons per meter. N, remember. Most stretchy objects will obey Hooke's law, but only up to a certain force. After that, an object gets stretched so much that it can't spring back to its original shape. Springs are unusual because that extension at which Hooke's law stops working is much higher for them than it is for most materials. When a stretched spring holds a weight, it is in equilibrium. When an object is in equilibrium, the forces acting on it are balanced, and it does not move or deform further. If you hang a weight from a spring, the spring stretches until the upward force from the spring equals the downward force of gravity on the weight. At this point, the forces are balanced, and the system is in equilibrium. Equilibrium is basically just a fancy way of saying the forces are balanced. Understanding force and elasticity has many practical applications, such as in engineering, construction, and everyday objects.